Let's start with the first example. Imagine that you're working as a supply and logistics manager and want to organize your supply chain more efficiently. You realize that you have some products with sales that are more variable than others. It's impacting your ability to deliver the right goods at the right time. On the one hand, you could decide to maintain huge stocks for all your products, and you would ensure the product availability by doing so. But it would be really expensive to implement in practice. On the other hand, you could wait up to the last minute before deciding on the production, which would be cheaper, but your ability to deliver the product on time would be negatively impacted. A simplistic approach to this problem, but similar to what's used in the industry, would be to analyze the question along two dimensions. You could plot the average daily sales of the stock keeping unit, the SKU, as a function of the volatility of daily sales of this SKU. The volatility of something may be measured with the coefficient of variation. For instance, in this case, the coefficient of variation is the standard deviation of sales divided by the mean sales for this SKU. We can then identify groups of SKU that are similar to each other visually. For instance, we can split both the variability and the average sales dimension in two, and group the two bottom cases, that is, SKUs with smaller average sales together. We then have three cases. One, SKUs with high sales and low variability. Let's call them horses, because those products are strong and reliable. Two, SKUs with high sales and high variability. Let's call them wild bulls, because they are strong but difficult to control. And three, let's consider all the other ones together, low sales, and call them crickets, because they are small but can jump unexpectedly. We'll then manage our supply chain differently for those three cases in order to ensure maximum efficiency. Horses' supply chain will be organized as what we call make-to-stock. They'll be made quickly available for sales by forecasting the demands and preparing the production in advance. It may seem expensive to keep everything in stock, but the benefits cover largely the costs, because sales are expected to be high and the risk of inaccurate forecast is low, since coefficient of variation is small in this case. Cricket's supply chain will be make to order. We'll wait to have an order before starting the production process. Since the sales are small in any case, it's not really efficient to prepare the production too long in advance. So we want to reduce the risks by producing the goods only if the order is made by the end of the chain. Wild bulls will be treated on a case-by-case basis. It's okay, because there are only a few of them. Sales may be difficult to anticipate, but the return may be high. So let's be pragmatic and assess the situation in each case specifically. In practice, you can multiply the splits by dimensions. For instance, if you do a 3x3 analysis, you would have what is called an ABC XYZ analysis, and you may have a finer segmentation of your SKUs and a resulting design of your supply chain that is more detailed. Note how clear our result is. We limited our analysis to only two dimensions here, but it makes the results very easy to understand. And the fact that we decide to use images and names for the different groups of products will ensure that audience will remember our conclusions. It will foster the adoption of the message we want to convey. When you can, always try to summarize your conclusions in a 2x2 matrix, or at least with two axes, as we did here. And always name your segments in a meaningful, self-explanatory and memorable way, even if it's not always easy to do. A picture is worth 1,000 words. During the different examples we'll cover, we'll always try to come with a visual representation that makes our results more meaningful and convincing. Note that all those examples are reusable for other applications, as we provide our R script during the recital at the end of this module that is easily adaptable to other contexts and other datasets.